January 30th, 1943. 11 a.m. Reich Broadcasting House, Berlin. Reichsmarschall Hermann Göring stood before the microphones, prepared to deliver the most important speech of the Nazi calendar, the 10th anniversary of Hitler's seizure of power. The German nation waited. Radio stations across occupied Europe stood ready to broadcast his words. This was the moment to project strength, to reassure a population beginning to doubt victory, to demonstrate that Germany remained invincible. Then the air raid sirens began to wail. At 25,000 feet above the German capital, 3 aircraft approached at speeds exceeding 400 miles per hour. They were not the lumbering 4-engine heavy bombers that German fighters had learned to intercept. These were sleek twin-engine aircraft constructed almost entirely from plywood and balsa wood, the Havilland Mosquitoes, the wooden wonder that Nazi propaganda had dismissed as evidence of British desperation. Göring's speech cut off mid-transmission. For over an hour, chaos reigned inside the broadcasting station as technicians scrambled to restore the connection. When Göring finally spoke, witnesses described him as boiling with rage, his face flushed with humiliation. His famous boast from September 1939 echoed mockingly through German minds. No enemy bomber can reach the Ruhr. If one reaches the Ruhr, my name is not Göring. You may call me Meyer. Now enemy bombers had struck Berlin itself, in broad daylight, on the most important date on the Nazi calendar. And they had done so with wooden airplanes that Nazi ideology insisted represented British industrial inferiority and technological bankruptcy. The Mosquito attack that morning involved 6 aircraft total. 3 from No. 105 Squadron struck first. 3 more from No. 139 Squadron followed in the afternoon, timed perfectly to disrupt Propaganda Minister Joseph Goebbels' scheduled address. 5 aircraft returned safely to base. 1 Mosquito was shot down by anti-aircraft fire, both crewmen killed, proof that even the wooden wonder was not invincible. But the mathematics were devastating for German morale. German fighters had been unable to intercept any of the attacking aircraft. By January 1943, Mosquitoes had flown over 600 operational missions against Germany with loss rates below 1%. Compare that to RAF conventional bombers, which suffered loss rates exceeding 5% per mission. A wooden airplane, which Nazi propaganda claimed represented British desperation, was proving nearly untouchable. For Hermann Göring, commander of the Luftwaffe, this moment crystallized into an obsession that would consume German aviation resources for years to come. The Mosquito represented everything Nazi ideology claimed was impossible, a wooden aircraft built by a democracy Germany considered decadent, outperforming every metal fighter and bomber the Reich possessed. What happened next would trigger the most expensive attempt at technological mimicry in Luftwaffe history, a desperate race to copy what German engineers insisted could not work, a program that would fail spectacularly, destroyed not by enemy action but by the very industrial weaknesses the Mosquito had been designed to circumvent. This is the story of how envy led to catastrophe, how ideology blinded engineering judgment, and how Germany's attempt to copy the wooden wonder became a case study in why technological superiority requires more than brilliant design. It requires an industrial ecosystem capable of bringing that design to life. The story of the Mosquito began not in desperation, but in visionary engineering that contradicted every principle of modern aircraft design. In 1938, Geoffrey de Havilland began sketching a concept that seemed absurd on its face. As metal construction dominated aviation worldwide, de Havilland proposed building a bomber entirely from wood. No defensive armament. No armor plating. No self-sealing fuel tanks. Just speed, altitude, and the structural efficiency of composite wood construction. The British Air Ministry initially rejected the concept. How could wood compete with metal? How could an unarmed bomber survive in modern aerial warfare? The answers lay in mathematics, and in Geoffrey de Havilland's decades of experience with wooden aircraft construction. De Havilland had pioneered advanced wooden construction techniques with the DH.88 Comet Racer in 1934. 3 comets entered the London to Melbourne air race covering 11,300 miles in 71 hours. The comet's construction used layers of plywood and balsa wood bonded with adhesive, forming a stressed skin monocoque structure. This sandwich construction provided strength equal to metal at half the weight. He refined the technique further with the DH.91 Albatross airliner in 1937, which carried 22 passengers at speeds of 210 miles per hour, faster than contemporary bombers. When war erupted in September 1939, de Havilland recognized that aluminum would become critically scarce. Britain needed aircraft production to scale rapidly and would offered an elegant solution. Furniture factories, piano manufacturers, boat builders, all possessed skills to work with wood. These craftsmen could not build metal aircraft, but they could build wooden ones. On March 1, 1940, the Air Ministry issued Specification B.1/40, ordering 50 bomber reconnaissance variants of what would become the DH.98 Mosquito. On November 25, 1940, Geoffrey de Havilland Jr. took the prototype aloft from Hatfield Aerodrome. The flight lasted 30 minutes. Every expectation was exceeded. The Mosquito prototype, painted in bright yellow, demonstrated handling characteristics pilots described as fighter-like despite its size. The construction method was revolutionary. The fuselage comprised 2 halves, each built on massive concrete molds. Workers laid strips of birch plywood inside the molds, then a layer of Ecuadorian balsa wood, then more birch plywood. The layers were bonded with casein adhesive, a milk-based glue that proved remarkably reliable. After the adhesive cured, the 2 fuselage halves were joined along the centerline. The wings used similar sandwich construction. Douglas fir and spruce spars provided the structural backbone, with English ash forming wing ribs. Birch plywood and balsa formed the wing skins. Walnut reinforced critical bulkheads. The entire wing was built in one piece, requiring no rivets or fasteners. This construction technique offered advantages German engineers would later fail to appreciate. Wood provided excellent damage resistance. Bullets passed through without shattering the structure, unlike aluminum which cracked and peeled. Wood produced minimal radar returns, making the Mosquito harder to detect. Wood could be repaired in field conditions using basic tools. Most critically, wood eliminated dependence on strategic metals that Germany increasingly lacked. On January 16, 1941, the prototype raced a Spitfire in comparative trials. The Mosquito, a twin-engine bomber weighing twice what a Spitfire weighed, flew 20 miles per hour faster, 388 miles per hour at 22,000 feet. German intelligence officers who later reviewed these figures assumed they were propaganda fabrications. No twin-engine aircraft carrying bombs could outrun single-engine fighters. Yet the Mosquito did exactly that. The secret lay in power-to-weight ratio. 2 Rolls-Royce Merlin engines, each producing over 1,500 horsepower, drove the Mosquito's lightweight wooden airframe. The entire aircraft structure weighed approximately 14,300 pounds empty, while a comparable metal bomber would weigh significantly more. The wooden construction provided substantial weight savings while maintaining structural strength, translating directly into speed and altitude performance beyond anything Germany possessed. Before we continue with this extraordinary story of engineering brilliance and strategic failure, please take a moment to subscribe to our channel. Hit that like button and drop a comment letting us know where you're watching from around the world. Your support helps us bring these incredible World War II stories to light. Now, let's discover how Germany's attempt to copy the wooden wonder ended in one of aviation history's most spectacular failures. By summer 1942, Mosquitoes were operational in multiple roles that shocked German intelligence analysts. A single basic airframe fulfilled missions requiring entirely different aircraft designs in the Luftwaffe. Photoreconnaissance variants flew over Germany at 40,000 feet, beyond the ceiling of German fighters. Bomber variants struck precise targets with minimal losses. Fighter-bomber variants armed with 420mm cannons and 4.303 caliber machine guns proved devastatingly effective against German shipping. Night fighter variants equipped with airborne intercept radar downed German bombers over England. The versatility was unprecedented. The Mosquito could carry a 4,000-pound bomb load farther than most dedicated bombers. It could fight as a pure fighter despite carrying bombs. It could conduct reconnaissance missions lasting 8 hours. 42 distinct variants would enter service during the war. Production scaled with remarkable efficiency. The Havilland's factory at Hatfield built the prototypes, then production dispersed to furniture manufacturers across Britain. By 1943, companies that had built dining tables and pianos were assembling complete Mosquito fuselages. The workforce included women, older men beyond military age, and skilled craftsmen who could never have worked with metal aircraft. The operational record built steadily through 1942. Mosquitoes bombed Gestapo headquarters in Oslo, destroying records of resistance members. They struck precision targets across occupied Europe, losing aircraft at rates below 1%. By late 1942, German night fighter crews reported something ominous. British aircraft they could not catch were conducting reconnaissance missions across Germany with impunity. Reconnaissance Mosquitoes stripped of all unnecessary equipment achieved speeds of 420 miles per hour at altitude. German fighters climbing to intercept found empty sky. Mosquito pilots could see German fighters launching from bases below and simply accelerated away. 4 Luftwaffe pilots trained to believe in German technical superiority, the experience produced dangerous psychological effects. If they could not catch a wooden British bomber, what did that say about German aircraft design? The crisis escalated through early 1943. Mosquitoes began appearing over Berlin regularly, conducting what the British called nuisance raids. Small formations, sometimes just 2 or 3 aircraft, struck at irregular intervals day and night. They disrupted manufacturing, prevented workers from sleeping, forced constant alert status that exhausted defenders. German fighters scrambled repeatedly, burning precious fuel, achieving nothing. Anti-aircraft batteries fired thousands of rounds, hitting nothing. The Mosquito flew too high, too fast, too unpredictably to intercept with 1943 technology. Hermann Göring obsessed over the situation. At conferences with aviation ministry officials, he demanded explanations. How could the British build wooden aircraft superior to German metal designs? The answers he received contradicted Nazi ideology at every level. British engineers were not inferior. British industrial organization was not chaotic. British materials science was not behind German standards. The Mosquito existed because Britain had solved problems Germany had not even recognized. On March 18, 1943, Göring summoned Germany's aviation industry leaders to Carenhall, his vast hunting estate in the Scorpiide forest. For 6 hours he berated them while a stenographer recorded every word, creating a historical document revealing the depth of German frustration. Göring focused particular fury on the Mosquito's wooden construction. "I go mad when I look at the Mosquitoes," he raged. "I am green and yellow with envy. The Englishman, who has more aluminum than we do, is building a wooden machine, and with a speed which he now increases again." Professor Willy Messerschmitt sat silently during much of Göring's tirade. His company produced the Bf-109 fighter and Bf-110 heavy fighter, both all-metal designs. Neither could catch a mosquito at altitude. Göring turned to Messerschmitt directly. "You are supposed to be the greatest aircraft designer in Germany. Tell me why you cannot build a wooden aircraft capable of the performance we demand." Messerschmitt had no good answer. German aviation had committed entirely to metal construction, the industrial infrastructure, engineering expertise, and manufacturing processes all optimized for aluminum airframes. Converting to wood construction would require retraining workers, retooling factories, developing new adhesives, sourcing different materials. Germany lacked access to high-quality balsa wood from Ecuador. German furniture industry had different skills than British piano makers. The adhesive technology that made British wooden aircraft possible was not readily available in Germany. But Göring wanted a German Mosquito, and what Göring wanted, the aviation industry had to provide. Erhard Milch, Reich Minister of Aviation, decided that Focke-Wulf would lead the effort. Kurt Tank, chief designer at Focke-Wulf, had begun preliminary work on a wooden night fighter in late 1942. The project would receive top priority, unlimited resources, and a name deliberately chosen to invoke the British original. The Germans would call it the Mosquito. The Focke-Wulf Ta-154 represented German engineering attempting to replicate British empirical success. Tank proposed an aircraft superficially similar to the Mosquito: twin engines, wooden construction, 2 crew members, heavy armament for night fighting. The specifications called for speeds of 440 miles per hour, a ceiling of 37,000 feet, and a range of 1,000 miles. If achieved, these numbers would match or exceed the Mosquito's performance. Tank initially selected the Junkers Jumo 211 engine for early prototypes, a liquid-cooled inline engine producing 1,300 to 1,500 horsepower. However, the intended production engine was the more powerful Junkers Jumo 213, capable of 1,750 horsepower. The airframe would use wooden construction with strategic metal reinforcements. A special phenolic resin adhesive called Tego film, manufactured by Goldschmidt Company in Wuppertal, would bond the wooden components. The cockpit would be pressurized, a feature the Mosquito lacked. Armament would include two 30 mm Malawian Quachas 108 cannons and two 20 mm MG 151 cannons, firepower exceeding any British night fighter. On July 1, 1943, the first prototype took flight from Langenhagen Airfield. Test pilot Hans Sander reported excellent handling and impressive speed in subsequent test flights. Follow-on prototypes confirmed the promise. During competitive trials at Reckland Test Center, the Ta-154 outflew both the Heinkel He-219 and Junkers Ju 388. The lightly loaded prototypes without full armament and radar equipment reached nearly 440 miles per hour in level flight, an impressive figure that exceeded German night fighter performance, though production aircraft with operational equipment would prove considerably slower. German aviation officials celebrated. Finally, an answer to the British Mosquito. Production plans called for 37 aircraft by May 1944, scaling to 250 per month by November. Factories in Posen prepared for mass production. The Luftwaffe designated units to receive the new night fighter. Everything seemed on track. Then reality intervened. The Jumo 213 engines never arrived in required quantities. Junkers factories struggled with production problems. Engines allocated to the Ta-154 were diverted to other programs. By spring 1944, only a handful of prototypes existed, all fitted with lower-powered Jumo 211 engines that reduced performance below specifications. The airframe itself revealed problems. The wooden wing structure proved heavier than calculated. Additional strengthening was required, adding weight that degraded speed and climb rate. The landing gear designed for the aircraft's original estimated weight proved inadequate and required reinforcement. Internal politics threatened the program. Ernst Heinkel lobbied relentlessly for his He-219 night fighter. Luftwaffe commanders, particularly the night fighter units, preferred the He-219's superior radar and crew visibility. Erhard Milch fought to keep the Ta-154 alive, but opposition grew. Kurt Tank found himself defending his design against critics within his own government, even as the fundamental problem loomed. Germany was attempting to replicate in months what Britain had developed over years of wooden aircraft experience. Then, on the night of May 29, 1943, catastrophe struck, not on any German airfield, but in an industrial town 200 miles from Berlin. Over 700 Royal Air Force bombers attacked Wuppertal in one of the war's most devastating area bombing raids. The town held the Goldschmidt Company's factory, the only facility in Germany producing Tego film adhesive, the specialized phenolic resin that bonded the Ta-154's wooden structure together. The firestorm that engulfed Wuppertal killed thousands. Among the destroyed facilities was the Tego film production plant. Production ceased immediately. The immediate response was to source alternative adhesives. Dynamit Nobel AG in Leverkusen produced a phenolic resin adhesive used in other applications. This substitute was delivered to Focke-Wulf with assurances it would work adequately. What followed was catastrophic. On June 28, 1944, a Ta-154A-1 broke apart during a test flight. Investigation revealed the substitute adhesive had chemically reacted with the wooden structure, corroding the wood fibers and destroying structural integrity. In July 1944, two more Ta-154A-1 aircraft completed using the Dynamit Nobel adhesive took off for acceptance testing. One aircraft crashed when its wings disintegrated in flight. 3 more crashes followed in rapid succession. Each one revealed the same problem. The replacement adhesive was not just weaker than Tego film, it was actively destructive. Kurt Tank immediately grounded all Ta-154 aircraft and halted production. Engineers frantically searched for alternatives. None existed within Germany. Tego film required specific chemical processes and materials that could not be replicated quickly. The factory that produced it was gone, destroyed by the same British bombers the Ta-154 was designed to intercept. The irony was complete. Germany's attempt to copy the Mosquito failed because British bombers destroyed the one factory producing the adhesive that held the German copy together. On August 14, 1944, Tank formally ceased all production. On September 9, 1944, the Reich Aviation Ministry canceled the entire program. Approximately 50 production aircraft had been completed, most using the inadequate substitute adhesive. A few pre-production aircraft remained serviceable and were assigned to night fighter units for evaluation. Combat records suggest they achieved limited success against British bombers but were outmatched when encountering Mosquitoes. But the failure went far deeper than one bombing raid. The Ta-154 disaster revealed fundamental weaknesses in German aviation that would have doomed the project even without the Wuppertal attack. Germany lacked access to the high-quality materials the Mosquito used: Ecuadorian balsa, Canadian spruce, British birch. These were empire resources Germany could not obtain. German wood substitutes were heavier and less consistent. British adhesive technology, developed through years of experience building wooden racing aircraft and airliners, exceeded German capabilities. The casein glue used in British Mosquitoes proved reliable in all climates and conditions. German adhesives developed for furniture and construction could not withstand the stresses of combat aircraft. More fundamentally, Germany lacked the industrial organization to mass-produce wooden aircraft. British furniture factories converted smoothly to Mosquito production because the skills transferred directly. German furniture industry had different construction methods. Retraining workers, adapting factories, developing quality control procedures, all took time Germany did not have. The Mosquito had been in production since 1941. By the time Germany attempted to copy it in 1943, the British had solved hundreds of manufacturing problems and trained thousands of workers. Germany tried to replicate in months what Britain had developed over years. The few Ta-154 aircraft that reached operational units performed poorly compared to expectations. The Jumo 211 engines provided insufficient power. Top speed rarely exceeded 400 miles per hour, far below the Mosquito's performance. Climb rate was inadequate for rapid intercept. The wooden construction proved difficult to maintain in field conditions. Moisture damaged adhesive bonds. Temperature changes caused warping. Repairs required specialized skills and materials that forward units lacked. Most operational Ta-154s were grounded within weeks due to maintenance problems. Combat encounters with actual Mosquitoes proved humiliating. On March 16, 1945, a Junkers engineering report documented engagements between Ta-154 night fighters and British Mosquitoes over northern Germany. In every encounter, the Mosquito outran the German aircraft. The Ta-154 could not catch what it was designed to destroy. Its wooden construction, which should have provided performance advantages, instead added weight and maintenance burdens without delivering the speed necessary to compete. By April 1945, the remaining Ta-154 aircraft were withdrawn from combat operations. Some were used as training aircraft. A few were cannibalized for parts. Most were simply abandoned at airfields as Allied forces advanced. The total production run, including prototypes, numbered perhaps 70 aircraft. Compare that to nearly 8,000 Mosquitoes built by the Allies. The program consumed resources, engineering talent, and factory capacity that Germany desperately needed elsewhere. The return was effectively zero. The contrast between the Mosquito and Ta-154 illustrated broader patterns in wartime technological competition. The Mosquito succeeded because it was designed around available resources and industrial capabilities. Geoffrey de Havilland understood that Britain had skilled woodworkers, reliable adhesives, and access to quality materials. He designed an aircraft that exploited those advantages. The Ta-154 failed because it attempted to copy a design without understanding the industrial ecosystem that made it possible. German engineers saw the Mosquito's performance and assumed they could replicate it by copying visible features. They missed the decades of experience, the industrial infrastructure, the materials science, the trained workforce. They assumed wooden construction was simple because wood was a traditional material. They discovered too late that modern wooden aircraft required sophisticated engineering, specialized materials, and trained craftsmen as skilled as any metalworker. Meanwhile, the Mosquito continued its reign of dominance. Throughout 1944 and into 1945, Mosquitoes struck targets across Germany with impunity. They conducted the final RAF bombing raid of the European War, striking Kiel on May 2, 1945. Post-war analysis revealed just how thoroughly the Mosquito had dominated. In photo reconnaissance, no German aircraft could match its altitude, speed, or range. In night fighting, Mosquito night fighters achieved more kills against German aircraft than the Ta-154 achieved against British aircraft. In precision bombing, Mosquito bomber variants struck more targets with higher accuracy than any comparable German type. Hermann Göring's March 1943 tirade at Carenhall revealed not just frustration with British success, but a fundamental misunderstanding of why that success occurred. Göring believed that superior German engineering should automatically overcome any British advantage. He could not accept that British empirical, incremental development might produce better results than German theoretical approaches. He demanded a German Mosquito without understanding what made the British Mosquito work. The broader lesson extended beyond aircraft design. Nazi ideology consistently underestimated enemies it considered racially or culturally inferior. The Mosquito demonstrated that British engineering was not just competitive with German engineering but, in specific areas, superior. The aircraft's success came from practical problem-solving, not theoretical elegance. It came from leveraging industrial strengths, not forcing industrial capabilities into ideological patterns. It came from distributed production using available skills, not centralized manufacturing requiring specialized resources. Germany's failure to copy the Mosquito mirrored its failure to match Allied industrial production across all categories. By 1944, Allied factories outproduced German factories in every measurable category: aircraft, tanks, ships, trucks, artillery, ammunition. The industrial statistics tell their own story. Britain produced 7,781 Mosquitoes during the war. Germany produced approximately 70 Ta-154s. British Mosquito production employed distributed facilities requiring only woodworking skills. German Ta-154 production concentrated in vulnerable factories requiring specialized adhesives unavailable after May 1944. For the crews who flew Mosquitoes, the aircraft became legendary. Pilots praised its handling, its speed, its ability to bring them home despite damage. Post-war surveys found Mosquito crews expressed higher satisfaction with their aircraft than any other bomber type. They trusted the wooden wonder with their lives, and it consistently delivered. The legacy extended beyond World War II. The Mosquito influenced post-war aircraft design in multiple ways. Its use of composite construction presaged modern carbon fiber aircraft. Its multi-role versatility established patterns that continue in modern combat aircraft. The lessons learned building wooden aircraft transferred to modern composite materials that share many of wood's advantages. For Germany, the Ta-154 failure became a case study taught in post-war engineering programs. Students learned how technological ambition without industrial capacity produces failure. They studied the importance of matching designs to available resources. They examined how strategic decisions made in desperation often waste more resources than they save. The story illustrates a fundamental truth about wartime innovation. Technology alone does not determine outcomes. Industrial capacity, resource availability, workforce skills, organizational structure, all matter as much as engineering excellence. The Mosquito succeeded not because it was theoretically perfect, but because it was practically achievable within British capabilities. The Ta-154 failed not because German engineers were incompetent, but because they attempted to replicate something their industrial system could not support. The wooden wonder demonstrated that sometimes the best solution is the one that works with what you have, not the one that requires what you lack. Geoffrey de Havilland understood this principle. He designed an aircraft using resources Britain possessed, optimized for production Britain could achieve, suited to missions Britain needed to fly. Hermann Göring never understood this principle. He demanded an aircraft matching British performance without considering whether Germany possessed the industrial ecosystem to produce it. The result was predictable. British Mosquitoes flew over 15,000 operational sorties while German Mosquitoes barely flew at all. By war's end, the Mosquito had become one of the most successful aircraft designs in history. 7,781 built, 42 variants developed, service in air forces of 17 nations, operations on every continent where combat occurred. The Ta-154, by contrast, existed mostly as a series of prototypes and a pile of incomplete airframes. It represented resources wasted, opportunities missed, and the consequences of strategic decisions made from envy rather than analysis. Hermann Göring saw the mosquito and turned green and yellow with envy. That envy drove Germany to attempt copying what it could not produce. The failure was inevitable from the moment Göring demanded a German mosquito without first asking whether Germany could actually build one. In the end, the story was not about wood versus metal or British engineering versus German engineering. It was about understanding your strengths and designing solutions that leverage them. It was about recognizing that what works for your enemy might not work for you. It was about accepting that sometimes the other side has genuinely superior solutions, and trying to copy them without the underlying capabilities guarantees failure. The mosquito taught these lessons. The Ta-154 confirmed them, and Hermann Göring learned them too late to matter.